The countdown has begun. What if the worst-case scenario is already happening with 3I Atlas? We are told that 3I Atlas is natural because that is what data suggests. But in the shadows of speculation, a much darker possibility grows. What if it isn't leaving? What if the path we think is an exit is something else entirely? Imagine a probe so advanced it could mimic nature perfectly, hiding in plain sight as ice and dust. Imagine a civilization so cautious it sends watchers instead of messengers that never reveal themselves, only observe. If that's true, then 3I Atlas is not just a rock, but a message, or worse, a test. Tonight, we will journey into the precarious space between science and speculation, and why the 29th of October will reveal this comet's moment of truth. We'll weigh the natural against the unnatural, the science against the paranoia, comfort against dread, and ask a question both simple and terrifying. Is the worst-case scenario already happening? On the night of the 1st of July, 2025, a routine survey turned into a page from cosmic history. The Atlas telescope in Chile, built to catalogue the faint wanderers of our solar system, caught sight of something it was never designed to find. A speck of light, barely distinguishable from background stars, slid across the detector with just enough deviation to demand attention. At first glance, it was nothing unusual, a faint object, magnitude 14, moving slowly against the sky. The observatory's automated software flagged it for follow-up, part of the endless stream of asteroids and comets logged every week. But as astronomers began to refine its path, the numbers stopped behaving as they should. Asteroids bound to the sun trace neat ellipses. Comets stretch those ellipses into dramatic arcs. Even the wildest orbits eventually bend back toward our star, shackled by gravity's invisible tether. But this one refused to be bound. With each new measurement, the trajectory unraveled further from the familiar, until it became undeniable. The curve was not an ellipse at all, but a hyperbola, the mathematical fingerprint of something unshackled. The object was not circling the sun, it was passing by, a messenger from beyond. Within hours, the realization spread through the global network of observatories. Emails, late-night calls, hurried calculations, scribbled on paper, each independent confirmation deepened the growing sense of awe. For the third time in human history, we were witnessing the arrival of an interstellar visitor. The designation came quickly. 3I Atlas, the third interstellar object catalogued by science, its name honoring the very telescope that spotted it first. News of the discovery rippled outward. Journalists scrambled for comparisons. Oumuamua in 2017, Borisov in 2019. Strange objects that had teased us with possibilities before vanishing back into the dark. But almost immediately, there was something different about this one. Its speed, its brightness, its chemistry hinted at by preliminary spectra. From the moment it was noticed, Atlas carried the weight of mystery heavier than its icy nucleus. In those first days, before the headlines sharpened and speculation took hold, there was only the raw astonishment of discovery. A faint dot on a screen that connected us to the vast machinery of the galaxy. Somewhere far beyond our neighborhood, around a star we may never identify, forces had flung this fragment into interstellar exile. For millions or billions of years it had wandered unobserved, until chance brought it into alignment with a small telescope on a mountain in South America, and through that lens, into human awareness. The discovery of Atlas was not accompanied by fireworks or sirens. No sudden flash across the night sky announced its arrival. It came quietly, as most cosmic revelations do, slipping into our data streams like a whisper. Yet within that whisper lay the opening line of a story that could stretch our imagination to breaking point. Because every interstellar object asks the same haunting question. What else drifts between the stars? And why did this one come to us now? Confirmation came not with fanfare, but with numbers, quiet, precise, and undeniable. Over 2 nights in early July, observatories across the globe turned their instruments toward the faint intruder first glimpsed by Atlas. Each telescope added new dots to the growing map of its path, and with each dot the truth sharpened. The orbit refused to close. Gravity could not hold it. What had seemed at first a wandering comet was now revealed as something stranger, a body moving too fast, on a line too straight to belong to our solar system. The calculations spread like a ripple through the scientific community. In data centers and control rooms, astronomers watched their models update in real time, elliptical orbits collapsing into a curve that opened outward forever. The eccentricity, a single number that defines whether an orbit is bound or free, crept higher with each refinement. 1.01, then 1.1, then higher still. Anything above 1 meant escape velocity, a trajectory never returning to the sun. By the morning of the 3rd of July, the verdict was unanimous. This was hyperbolic. This was interstellar. A third time in human history, the cosmos had delivered a traveler from beyond. Oumuamua, slender and enigmatic, had startled us in 2017 before vanishing with more questions than answers. 2 years later, Borisov had followed, a comet in every sense. Though still a foreigner from another star, and now Atlas joined their ranks, carrying with it the promise of new knowledge and new mysteries. For the astronomers, the realization brought a mixture of excitement and unease. To detect one interstellar object had felt like fortune. To detect 3 in less than a decade suggested something more. A galaxy teeming with these wanderers, countless fragments of alien star systems slipping silently through the void. If 3 had already been found by chance, how many more had passed unseen? How many had crossed our skies when no telescopes were watching? The press releases tried to capture the significance, but words felt clumsy against the weight of what the data implied. A piece of another solar system had entered ours. Its icy body had formed around a distant star billions of years ago, then been flung outward by some ancient planetary encounter. It had spent eons drifting between suns, carrying within it chemical signatures of its birthplace, until, at last, it crossed paths with Earth's instruments and left its mark in our records. There was something profoundly humbling in this confirmation. Our world had become, however briefly, a stop along a journey that had begun long before humanity existed and would continue long after we were gone. The object itself showed no awareness, no intent, only momentum, an ancient memory locked in ice and dust. Yet its presence forced us to look outward and ask harder questions. What stories do these visitors carry from the galaxy's far corners? And more unsettling still, what stories might they be writing about us? As they slip past, silent witnesses to our brief flicker of civilization. At first, it was nothing more than a provisional designation, a string of numbers and letters generated by the software that tracks new celestial objects. C2025, N1, a sterile label that placed it neatly in the taxonomy of comets and asteroids. Yet the moment its trajectory was confirmed as interstellar, the cold catalogue number no longer felt sufficient. Something that had crossed the gulfs between stars deserved a name that acknowledged its rarity, its strangeness, its role in human imagination. The International Astronomical Union moved quickly, following the convention established with its predecessors. Oumuamua had been 1I, the first interstellar object ever confirmed, its name drawn from Hawaiian for a messenger that arrives first, reaching out. 2 years later, Borisov became 2I, the second messenger, less poetic perhaps, but still marked by its discoverer. Now, this new wanderer was given its place in the sequence, 3I, the third. The rest followed naturally. Atlas, the telescope whose digital eyes first caught the faint flicker on the 1st of July, was honoured in the second half of the name. Together they became 3I Atlas. It was a simple designation, yet the transformation was immediate. A string of numbers now carried weight, meaning, and myth. Scientists could speak of it with ease, journalists could frame headlines around it, and the public could imagine it as something more than a data point. The name became a vessel for story. Language has always carried power in our relationship with the cosmos. The ancients mapped constellations into gods, hunters, lovers, and monsters, their names shaping how generations saw the night sky. Even today, a dry acronym can conjure awe when attached to the right discovery. To call this object Atlas was to place it in a lineage of cosmic messengers, each one more than just rock and ice, each one a symbol of the galaxy's hidden connections. Already, speculation gathered around the name itself. Atlas evoked the Titan of Greek myth, condemned to hold up the heavens, an unintentional echo that made the object feel larger than life. The third messenger became a phrase whispered in late-night forums, as if the universe itself were sending us a series of signals, one every few years, each stranger than the last. Oumuamua the first call, Borisov the second, and now Atlas, swifter and more chemically bizarre than either. To some, it felt like escalation. Names fix objects in memory long after their physical traces are gone. Oumuamua has long since faded from sight, Borisov disintegrated into dust, and Atlas will soon vanish into the dark. Yet, the names remain, etched into human history, touchstones for stories that stretch from cautious science to cosmic myth-making. This latest designation, born of cataloguing necessity, has already begun its metamorphosis. Atlas is not merely a comet on a hyperbolic path, it is a symbol of contact with the wider galaxy. A reminder that even in silence, the universe still speaks. And perhaps most unsettling of all, once a name is spoken often enough, it begins to feel less like a discovery and more like a character in an unfolding narrative. Atlas is no longer just passing through. It has entered our story. The first wave of reports came quickly, as they always do when a new object enters the astronomical record. Atlas was classified, described, and placed neatly in the box marked comet. The images revealed a faint halo of gas and dust, the telltale coma that blooms when sunlight strikes frozen ices. Its orbit, though extraordinary, was still predictable, its trajectory carrying it safely past Earth at a comfortable distance of 270 million kilometers. The official language was calm, measured, reassuring. There was no danger here, no threat to our world. Just another comet, albeit one born under an unfamiliar star. NASA's initial statement read almost like a sigh of relief. Yes, it was unusual. Yes, it was fast, but it was also safe. Journalists echoed the message, careful not to fan unnecessary panic. Interstellar visitors, after all, had a history of stirring more imagination than warranted. Oumuamua had been painted as an alien probe by some, only to slip away silently, leaving nothing behind but debates. Borisov had reassured us by behaving exactly like a comet should. Atlas seemed destined to follow that pattern. Another curiosity to be studied, catalogued, and then forgotten as it disappeared back into the dark. For the public, the early impressions were easy to digest. A comet. A visitor from another star, yes, but still a comet. Something that could be grasped, explained, domesticated by the language of science. The headlines leaned into wonder rather than worry. Third interstellar traveler confirmed, cosmic messenger from afar, a harmless visitor from the stars. It was a story that invited awe without demanding anxiety, an opportunity to marvel at the scale of the universe without confronting existential fear. Astronomers, too, found comfort in its apparent familiarity. The coma expanded as expected, responding to solar heating. The light curve, while faint, fit within known ranges. The absence of unusual radio emissions reinforced the narrative of normalcy. Observatories in Chile, Hawaii, and Spain logged spectra that showed carbon dioxide and dust strange in its ratio, but not impossible. For a brief moment, it seemed that Atlas would behave, playing the role of interstellar comet with textbook precision. And yet, beneath the surface of these early impressions, there lingered a quiet unease. The speed was too high, far greater than its predecessors. The chemical balance was unlike anything seen in local comets. The angle of approach, skewed against the galactic plane, hinted at origins older and stranger than the Sun itself. These details were tucked into the appendices of press releases and the footnotes of academic papers, acknowledged but not emphasized. To the wider world, Atlas was harmless, natural, ordinary, a comet like many before it. But to those who watched closely, who had seen how quickly ordinary can unravel into the inexplicable, the reassurance felt fragile. The first impressions were comforting, yes, but comfort has a way of dissolving once the deeper mysteries begin to surface. From the beginning, NASA understood the assignment. When the words interstellar object appear in headlines, the human imagination ignites in ways equations alone cannot extinguish. So the first official statements arrived, wrapped in the language of precision, control, and calm. No threat to Earth, the press release read. Closest approach, 1.8 astronomical units, nearly twice the distance between Earth and Mars. Numbers meant to anchor us, figures meant to soothe. In carefully measured tones, officials explained what the discovery meant, and more importantly, what it did not. This was not a collision course. It was not a planet killer. It was not, despite whispers in late-night forums, an alien craft scanning our skies. Atlas was, they insisted, a natural comet from another star system, passing harmlessly through before continuing on its hyperbolic path into the interstellar night. The briefings emphasized heritage, continuity. NASA had done this before. Oumuamua had come and gone without incident. Borisov had burned bright and then faded, and Atlas would do the same. The math was reliable. The models were solid. Celestial mechanics left no room for doubt. The universe, chaotic though it may appear, still bent to the laws of physics, and those laws predicted safety. To many, the tone felt like a lullaby spoken in the language of science. Numbers whispered like a reassurance. Eccentricity greater than 1, perihelion at 1.4 AU, trajectory already mapped years into the future. There would be no surprises, no sudden veer toward Earth. It would not even come close enough to warrant planetary defense exercises. This is an opportunity, the officials repeated, not a hazard. And yet, the very precision of these reassurances carried an unintended undertone. The confidence was absolute, but it had to be. If there were doubts, they could not be shared. The public, already primed to see menace in the unexplained, required certainty. But certainty in the face of the unknown is a delicate mask, one that can crack when details begin to emerge. The statements avoided mention of the odd chemistry, the unusually high carbon dioxide signature, so unlike anything found in local comets. They noted the extreme velocity but framed it as a curiosity, not a concern. They did not dwell on the angle of approach. Steep against the galactic plane, suggestive of origins in the thick disk where ancient stars still circle. These details were for the journals, not the evening news. For the casual observer, NASA's words were enough. Safety was assured, the cosmos remained under control, and humanity could go on with its daily rhythms while an alien-born comet blazed invisibly across the depths of space. But for those who listened closely, the silences spoke as loudly as the reassurances. Numbers may banish fear, but they cannot silence the questions that lurk just beyond the reach of certainty. Was it truly harmless? Or was the worst case not about impact at all, but about what we might learn and what we might never be able to unlearn? Speed has always been the quiet tell in astronomy. The way an object moves tells you not only where it's going, but where it has been, what forces have touched it, and what history lies etched into its trajectory. With Atlas, the numbers spoke louder than any photograph. 61 kilometers per second, more than 130,000 miles per hour. A velocity that dwarfed its predecessors, nearly doubling the pace of Oumuamua and leaving Borisov trailing behind like a slow caravan in comparison. At first, this fact was packaged neatly as another curiosity. Yes, it was fast. Yes, faster than expected. But interstellar space is vast and violent, and objects flung from their birth systems carry scars in the form of momentum. Still, the deeper the models ran, the more uneasy the data became. The simulations didn't add up. The object hadn't just wandered here, it had raced, and not in a way that current models fully explained. Planetary ejections, gravitational slingshots, encounters with giant worlds in early star systems. These processes can accelerate debris, yes, but there are limits. Energy budgets in astrophysics are not infinite. To see an object moving at this speed suggested something more than the ordinary chaos of planet formation. Some theorized it had passed close to multiple stars in its long history, stacking accelerations across eons like compound interest. Others wondered if the velocity pointed to an origin not in the familiar thin disk of our galaxy, but in the ancient thick disk, where stellar dynamics were harsher, or even beyond. in regions of the Milky Way we barely understand. And yet, in the quiet corners of discussion, there were other questions, the kind not raised in official press briefings. Was the speed random? Or was it telling? Could acceleration of this kind ever be mistaken for something else, something deliberate? When Oumuamua passed through, Harvard astronomer Avi Loeb famously suggested it might be a light sail, pushed by starlight across the gulfs. That idea had been dismissed by most, filed away as provocative speculation. But here was another interstellar object, moving even faster, and once again the model strained at the edges of plausibility. NASA's official line remained firm. Natural explanations sufficed. Multiple gravitational encounters over billions of years could account for the velocity. The laws of physics held, even at 61 kilometers per second. But in the subtext, in the uneasy glances of researchers when cameras weren't rolling, lay the awareness that speed, unlike shape or chemistry, leaves little room for interpretation. Something had driven this ancient wanderer to a pace that few had anticipated, and it was already here, cutting through our solar system with the precision of a cosmic blade. The problem with speed is not just what it reveals about the past, it's what it means for the future. At such velocity, Atlas cannot be captured by our sun. It will not linger. It will pass through, reveal itself only briefly, and vanish forever. And in that fleeting encounter, humanity must decide whether what it sees is simply another comet, or a messenger carrying truths we are not yet ready to face. When the James Webb Space Telescope turned its mirrors toward Atlas, astronomers expected refinement, not revelation. Spectroscopy has a way of cutting through uncertainty, breaking light into molecular signatures that tell stories of composition, temperature, and history. But the story that came back was not the one anyone anticipated. The readings showed a coma dominated not by water vapor, the bread and butter of ordinary comets, but by carbon dioxide. Not just elevated levels, but an 8-to-1 ratio, so extreme it rewrote every assumption about what a cometary body should be. On Earth, carbon dioxide is a familiar ghost. We exhale it, we fear it, we regulate it. In comets it plays a role, but always secondary, always subordinate to water ice. Water sublimates easily in the warmth of sunlight, creating the glowing halos that mark comets across the sky. CO2, by contrast, is usually the supporting actor, appearing in smaller quantities, detectable but never dominant. Until now. The data from Webb was met first with disbelief, then with silence, then with the kind of careful rechecking that betrays quiet unease. Could the instruments be wrong? Was calibration off? Repeated measurements dismissed those hopes. The ratio held. Atlas was breathing carbon dioxide in volumes that made no sense, not for something drifting through interstellar space for billions of years. Theories rushed in to fill the gap. Perhaps the comet had formed near its parent star's CO2 snowline, where temperatures favored carbon dioxide over water ice. Or maybe cosmic rays had processed its surface across geological ages, sealing water beneath a crust while allowing CO2 to escape. Another possibility was the presence of an insulating dust mantle that protected water ice, while letting carbon dioxide percolate outward. Each explanation was plausible, elegant in its own way, but none felt entirely satisfying. The strangeness wasn't just the chemistry, but the timing. At over 3 astronomical units from the Sun, where most comets remained quiet and inert, Atlas was already active, already shedding gases in defiance of expectation. It was as though it couldn't wait, as if some deeper mechanism was stirring it awake long before the usual cues. Publicly, NASA described the chemistry as unusual but informative. A valuable clue to planetary formation in other star systems, they said. A rare chance to glimpse alien conditions preserved in ice. But privately, some scientists wondered if the oddity carried implications beyond simple origin stories. Why this much carbon dioxide? Why this early activity? Why now? The human mind, ever hungry for meaning, drifted toward more unsettling interpretations. What if the chemistry wasn't just a relic of ancient formation, but something designed, something engineered? What if the ratios weren't random, but deliberate signatures rather than substances? The thought was quickly dismissed in official circles. but it lingered like static at the edge of reception. In the end, the chemistry puzzle left more questions than answers. Atlas was no longer just fast, no longer just strange in its trajectory. It was chemically alien in a way no comet had ever been. And as it continued inward toward the sun, astronomers knew the puzzle was only beginning to unfold. Silence in the cosmos is never just silence. Every star hums, every planet radiates, every comet whispers in static bursts of natural noise. Space, contrary to imagination, is not quiet at all. It is saturated with the chatter of physics. That is why when radio telescopes turned toward Atlas, astronomers expected something, anything, however faint. The sublimation of gases, the interaction of charged particles with solar wind, the natural hiss of a comet alive under starlight. There should have been the familiar background chorus. Instead, what they heard was nothing remarkable. No narrowband signals, no modulated transmissions, no patterns that might suggest intelligence. Just the bland murmur of a comet doing what comets do. Officially, this was confirmation of normalcy. No alien beacon, no interstellar broadcast, no technological anomaly hiding in the static. In fact, the silence became another reassurance, folded neatly into NASA's narrative. Atlas was natural, and radio silence proved it. But for those who dwell in speculation, silence is not the absence of signal. It can be the signal. The dark forest hypothesis has haunted SETI for years. The idea that advanced civilizations might choose to remain hidden, suppressing transmissions to avoid detection by predators in the galactic night. In such a cosmos, silence becomes strategy. The absence of communication is not emptiness, it is survival. If Atlas were a machine or a messenger, what better disguise than silence? A comet that behaves like a comet, emitting nothing more than the hiss of gas and dust, would slip past every watchful ear. And yet, silence is a tricky thing to interpret. Was it deliberate, or was it simply the way of nature? The telescopes scanning Atlas reported nothing more exotic than broad-spectrum noise, but that result also matched the simplest camouflage. If an advanced probe wished to pass unnoticed, it would mimic the randomness of natural emissions so perfectly that even the most sensitive instruments could not tell the difference. The question then becomes one of intent. If silence is chosen, it suggests awareness of us, of detection, of the risks of being known. But if silence is imposed, a byproduct of design so subtle it hides even from our paranoia, then perhaps the signal we seek is not in what we hear, but in what we don't. The scientists did their due diligence. Dozens of radio arrays across the world listened. Arecibo's successors, the vast dishes of the Deep Space Network, even amateur SETI projects hungry for discovery. The verdict was unanimous. Atlas was quiet. Quiet in the way space debris is quiet, in the way ancient ice drifting between stars is quiet. And still, a discomfort lingered. Because silence, in this case, was louder than noise. It was definitive. It was as if the object had passed an audition for being unremarkable and had done so flawlessly. Too flawlessly. If something wanted to remain hidden, what better mask could it wear than the silence we have already convinced ourselves to expect? Trajectories tell stories long before chemistry or imagery can. The path of an interstellar object is not random. It is the fossil record of gravity itself, shaped by encounters stretching back across billions of years. When astronomers traced the orbit of Atlas, they noticed something unsettling in its geometry. Unlike most visitors to our solar system, which tend to arrive in the general flow of the galaxy's thin disk, moving with the broad rotation of stars around the Milky Way's center, this one came from an odd angle. It cut across the sky not as a fellow traveler, but as a stranger, tilted and skewed, as though it belonged to an older, more chaotic population. This immediately drew comparisons to the galaxy's thick disk, that ancient stellar component populated by stars with eccentric, tilted orbits. The thick disk is older than the Sun, older than the spiral patterns we find familiar, older even than many of the metals and elements that make up Earth. If Atlas emerged from that population, then it is not just interstellar, it is intertemporal. A survivor from an era when the Milky Way was raw and violent, when collisions between protogalaxies stirred stars into chaotic patterns, and when icy fragments like this one were flung into gulfs they would wander for eons. The oddity of its trajectory raised both excitement and unease. Excitement because a thick disk origin meant Atlas could carry chemical records of a galaxy we no longer inhabit. Unease because such an origin implied antiquity so extreme that it forced uncomfortable questions. Could this really be debris that had survived billions of years? Longer than complex life has existed on Earth? How does something so relatively fragile endure cosmic ray bombardment, interstellar dust collisions, and gravitational disruptions for geological ages without being destroyed? The orbital inclination seemed to whisper, "This is not recent, not ordinary." The simulations only deepened the mystery. Most interstellar objects traced back to plausible ejection scenarios around familiar star systems. Atlas did not. Its approach angle fit no simple lineage. Instead, it bore the marks of a history written in erratic encounters, perhaps even one that began outside the regions of the galaxy we usually study. It had travelled on its own schedule, ignoring the galactic currents, like a relic adrift. For some, this was enough. The orbit confirmed what spectroscopy had already suggested. Atlas was an ancient messenger, older than the solar system, bearing witness to the Milky Way's formative epoch. For others, the angle was too strange, too deliberate seeming. If an object wanted to arrive undetected, wouldn't it avoid the main thoroughfares, slipping in from directions where fewer eyes were pointed? NASA stressed the natural explanations: orbital eccentricity, galactic scattering, random chance. Yet the eccentric trajectory lingered in the imagination like a riddle. Not threatening, not explainable, but undeniably odd, a curve written against the canvas of the stars, hinting that the true story of Atlas is older and stranger than any we have yet dared to tell. Every comet has its moment of truth, the instant when it draws nearest the sun and either flares with brilliance or crumbles into silence. For Atlas, that moment was marked on calendars almost as soon as its orbit was calculated. The 29th of October, 2025. The date loomed like an astronomical deadline, a countdown not just to a physical turning point, but to an unveiling. Perihelion, the close brush with sunlight, would strip away ambiguity. Heat, relentless and impartial, would test whatever secrets lay frozen inside this interstellar wanderer. Telescopes worldwide were booked months in advance. Ground-based observatories would track the brightening coma as solar radiation sublimated ice into gas. Hubble would capture images as long as Earth's atmosphere allowed. The James Webb Space Telescope would watch with its spectrographs tuned, ready to catch whatever molecules boiled off as temperatures surged. Amateur astronomers, too, prepared for the spectacle, their smaller scopes waiting for the faint smudge to blossom into something visible against the night sky. Excitement buzzed not because anyone expected catastrophe, but because perihelion is the great revealer. Will the comet brighten dramatically, spraying tails of gas and dust that paint the sky? Or will it fracture, its nucleus splitting apart under the stress of heat and outgassing, leaving behind only a fading smear of debris? For an ordinary comet, both outcomes are plausible. For Atlas, the stakes felt higher. Its chemistry was already strange, its trajectory unsettling. What would happen when the sun poured its full energy onto an object that had not been warmed this way for billions of years? Some speculated the heating might unlock water ice hidden beneath the carbon dioxide crust, shifting the molecular balance and revealing deeper layers of its story. Others wondered if the unusual CO2 dominance would only intensify, flooding space with carbon in proportions never before seen. The most speculative, of course, whispered about activation, about dormant systems buried in ice, waiting for the cue of sunlight to awaken. If Atlas were more than comet, perihelion would be the stage where it dropped its disguise. NASA's language remained calm, precise, unfaltering. Perihelion would bring no danger to Earth. The object's distance, nearly 1.5 astronomical units from the Sun at closest approach, kept it safely out of range of planetary disruption. But even the official press releases admitted curiosity. The chemistry was unusual, the behavior unpredictable, and the data potentially groundbreaking. As the days ticked down, it felt less like waiting for a comet and more like anticipating an arrival. Each night's sky seemed to hold its breath. Astronomers sharpened their instruments. Journalists prepared headlines. Even casual sky watchers began to ask, what happens when it heats up? Because when ancient ice meets modern sunlight, something always changes. The question was not whether Atlas would reveal itself, but what, exactly, it would choose to reveal, and the countdown to that revelation had already begun. The comfort of a hyperbolic orbit lies in its simplicity. The math says the object comes in fast, swings around the sun, and departs just as fast, never to return. It is the cosmic equivalent of a passing stranger, curious perhaps, but gone before you know it. That was the reassurance offered when Atlas was discovered. Its eccentricity greater than 1, its velocity too high for capture, its fate written in geometry. But reassurance has a way of cracking when imagination takes hold, and a darker possibility begins to creep in. What if the flyby is not departure at all? What if it is deceleration? In orbital mechanics, speed is everything. Too much, and you escape forever. Too little, and you fall captive. What if Atlas carries the means, natural or otherwise, to alter its velocity at precisely the right moment? To shed just enough speed to shift from an interstellar trajectory into something more permanent. The sun, after all, is not just a source of light. It is a brake, a well of gravity that can slow as well as fling. For spacecraft designed by human hands, slingshot maneuvers around planets are routine. What if, for something far older and far more advanced, stars themselves serve as the ultimate engines of deceleration? Such speculation finds no evidence in the data. Every measurement of Atlas aligns perfectly with a natural hyperbolic escape, and yet the perfection itself unsettles. Objects flung from stellar nurseries should wobble slightly, betray scars of their chaotic origins. But Atlas glides with serene predictability, as though rehearsed. If one were to design a trajectory to mimic nature, would it look any different from this? The eerie thought is not that Atlas will crash into us or linger near Earth. The distances remain too vast for that. The unsettling possibility is that its path has been chosen not for escape, but for insertion, to drift into a stable orbit in the outer solar system, to vanish into the clutter of the Kuiper belt, indistinguishable from icy debris, to stay. Silence would still reign. No transmissions, no sudden course corrections, nothing overt to betray intent. Only the quiet act of slowing down, of remaining where the math insists it should not. The greatest disguise is not in hiding, but in pretending to leave and then never actually going. NASA has dismissed such notions, confident in the calculations. And perhaps rightly so, gravity does not lie, and hyperbolas do not bend themselves. But the very act of considering the alternative forces us into an uncomfortable awareness. Our models of nature are so precise that anything wishing to imitate nature need only match them to perfection. So, the question lingers, not in equations, but in imagination. What if Atlas is not a fleeting messenger at all? What if the worst-case scenario is already happening, not a collision, not destruction, but a quiet arrival disguised as departure? Nature has always been the perfect camouflage. To hide in plain sight among the chaos of comets and asteroids requires no invisibility cloak, no exotic force fields, only imitation. For a civilization advanced enough to traverse the gulfs between stars, disguising technology as ice and dust might be child's play. And Atlas, with its coma of carbon dioxide and dusty tail, offers an unsettling case study in how convincingly that disguise could work. Comets are messy, inconsistent, prone to fragmenting and sputtering as they near the sun. Their brightness flares unpredictably. Their spectra vary from one to another, sometimes rich in water, sometimes in carbon monoxide or methane. Inconsistency is their signature. So when Atlas presented astronomers with an anomalous composition, carbon dioxide dominating in ways never before seen, it raised questions, but none that demanded exotic explanations. After all, comets are supposed to surprise us. That is what makes the disguise so perfect. If one wanted to mask a machine beneath layers of natural material, the logic would be simple. Wrap it in ices, coat it with regolith, ensure that every outward signal matches what astronomers expect from frozen debris. When sunlight strikes, let it vent gas. When viewed through a spectrograph, ensure the ratios remain just odd enough to be chalked up to formation under unusual conditions. From the outside, nothing seems amiss. Only a whisper of strangeness lingers. The idea that alien technology could masquerade as a comet is not new. Decades of speculative thought in the search for extraterrestrial intelligence have circled this possibility. Bracewell probes, von Neumann machines, silent observers seated among the stars, all could wear the mask of a natural body. The key would be subtlety, not spectacle. Not glowing beacons or obvious structures, but chemistry tuned to blend with background noise. Atlas, if it were such a thing, would have succeeded brilliantly. Its speed, while high, matches natural expectations of an ejected interstellar body. Its trajectory follows the clean geometry of a hyperbola. Its coma glows just as theory predicts when ices sublimate under solar heat. Every test applied to it so far has confirmed what it appears to be: a comet. And yet this very perfection unsettles. For what better way to avoid detection than to match every expectation of nature exactly? NASA insists on natural explanations, and the evidence supports them. But the silence, the odd chemistry, the flawless mimicry all leave open a sliver of unease. If alien technology wished to hide, it would not do so in steel and circuitry, but in ice and dust. Not as something extraordinary, but as something ordinary, something we would never think to doubt. And so Atlas passes our instrument's gaze, every measurement confirming its naturalness, every confirmation deepening the irony. Perhaps the greatest deception is not in what is hidden, but in how convincingly the ordinary can conceal the extraordinary. Imagine a civilization so ancient, so patient, that reconnaissance does not arrive in gleaming craft or roaring engines, but drifts toward us disguised as the most ordinary things in the sky. Not saucers, not signals, but comets. To human eyes, they are harmless wanderers, ice and dust baked into erratic tails by sunlight. To alien eyes, they could be the perfect surveillance devices, slipping unnoticed into planetary systems under the guise of natural debris. This is the unsettling premise of the surveillance hypothesis: that some interstellar objects are not accidents of gravity but deliberate insertions. Comets, after all, are everywhere. They come from the Oort cloud, the Kuiper belt, the scattered disk. They are expected, messy, and unremarkable. When astronomers detect one on a strange trajectory, the instinct is to catalogue, not to panic. What better camouflage for a probe than the very objects our telescopes are trained to ignore? Atlas lends itself to this speculation uncomfortably well. Its hyperbolic trajectory fits what a true interstellar visitor should follow. Its speed, while astonishing, remains within the bounds of possibility. Its coma behaves as expected when the sun's heat strikes its frozen skin. Every observation so far confirms the comet narrative. And yet its peculiar chemistry, carbon dioxide overwhelming water in unprecedented ratios, hints at strangeness. To most scientists, this is a puzzle of formation history. To others, it's a possible signature of design. If one wished to conceal sensors, instruments, or even dormant machines, why not wrap them in exotic ice that produces exactly the kind of anomalies nature already provides? The logic behind cosmic surveillance is chilling. Launch a fleet of disguised probes, scatter them across the galaxy, and wait. Some will be destroyed, others lost, but a few will drift silently into developing systems. There, without revealing themselves, they can watch. They can listen. They can catalogue the rise of civilizations like ours without ever needing to announce their presence. To us, they remain indistinguishable from comets. To them, we are an experiment observed from a distance. Of course, the evidence remains firmly on the side of the mundane. No anomalous signals have been detected. No course corrections betray hidden propulsion. Every wobble in Atlas's path can be explained by the faint push of outgassing. And yet, the absence of proof is not proof of absence. A truly advanced probe would not broadcast its presence. Its very survival would depend on remaining undetectable, folded seamlessly into the background of the universe. The surveillance hypothesis, then, is less about proving alien intent and more about unsettling our assumptions. It reminds us that not every visitor need arrive in spectacle. Some might prefer silence, subtlety, and patience, measured in eons. As Atlas sweeps past the sun and prepares to depart, the question lingers like a shadow behind the data. Was this merely a comet? Or was it watching us all along? Astronomy has always read chemistry like a language. Each line in a spectrum is a syllable, each ratio a word in the story of a star, a planet, or a comet. When sunlight strikes an icy nucleus and molecules escape into the void, they carry with them information written in wavelengths of light. For most comets, the story is familiar. Water dominates, with supporting roles for carbon monoxide, methane, ammonia. But Atlas has disrupted this familiar grammar. Its lines sing almost exclusively of carbon dioxide. Its ratios strange, unnatural, like a sentence written in a dialect no one has ever heard before. To most scientists, the explanation is straightforward enough. Perhaps it formed farther from its natal star, beyond a CO2 snowline where carbon dioxide condensed in abundance. Perhaps its surface chemistry was altered over billions of years by cosmic rays, creating a crust that locks water in while allowing CO2 to escape. These are natural scenarios, plausible and grounded in known processes. And yet, for some, the thought lingers, what if this chemical oddity is not simply an accident of formation, but a deliberate signal? Encoding information in chemistry would be a masterstroke of stealth. A probe broadcasting in radio can be detected and intercepted. A machine with visible structures can be photographed and questioned. But chemistry masquerades as nature itself. Every astronomer expects comets to be chemically diverse, to surprise us with odd ratios and unusual volatiles. To hide meaning in those ratios would be to use our own expectations against us. Imagine a civilization that thinks on timescales beyond our comprehension. It seeds the galaxy with disguised messengers, each one carrying chemical signatures tuned not just to survive eons, but to convey information when finally observed. Ratios of CO2 to H2O could form a code, patterns too precise to be coincidence, yet subtle enough to be dismissed as natural variance until someone looks closer. A repeating prime sequence, a ratio matching physical constants, a pattern that whispers, "We were here." Nothing in the current data confirms this. The Webb spectra show strong carbon dioxide, weak water unusual but not beyond imagination. The coma behaves as physics dictates, sunlight heating volatiles until they escape into space. No prime numbers emerge, no encoded constants reveal themselves, and yet, the very act of measuring raises the question, how would we know if chemistry itself carried a message? Do we even have the tools to read such a code, or would it pass us by as noise in the background of the universe? The safest answer is that Atlas is natural, a relic of alien geology, not alien intention. But speculation persists because the silence of space leaves room for wonder. In that silence, chemistry might be more than frozen gas. It might be the medium of a message, an alphabet written in ratios of ice and dust, waiting for us to learn how to read. There is a theory whispered in the halls of astronomy and sharpened in the pages of science fiction. A theory as chilling as the vacuum between stars. It is called the dark forest. The idea is simple, brutal, and terrifying. The universe is a forest at night, and every civilization is a hunter, moving silently through the trees. To reveal yourself is to risk annihilation. To remain quiet is to survive. In this view, silence is not absence, it is strategy. When Atlas glides through our solar system without a sound, it could be nothing more than a comet, a frozen relic of another sun's nursery. Yet the stillness carries an unease. No signals, no strange emissions, no controlled maneuvers, just the quiet glow of a coma and the predictable arc of a hyperbola. Everything fits the profile of natural behavior. But if the dark forest hypothesis is true, then silence is precisely what we should expect from intelligence advanced enough to endure across cosmic time. Imagine for a moment that Atlas is not simply a comet, but a probe. Its mission would not be to announce itself, not to beacon across the void with radio waves, not to draw attention. Its mission would be to listen, to watch, to blend into the noise of nature and record what it sees. Because in a universe where survival depends on secrecy, the most dangerous act is to speak. This turns our perspective inside out. For decades, humanity has scanned the skies, hoping to hear something, an artificial signal, a narrowband transmission, anything that would break the silence. We've sent our own messages too, from the Pioneer plaques to the Voyager golden records, whispers into the dark in the hope that someone is listening. But if the forest is truly dark, then these acts may be less like greetings and more like flares, revealing our position to predators we cannot yet imagine. Atlas may be nothing more than ice and dust, a wanderer shaped by gravity and time. But its presence stirs the question, what if the worst-case scenario is not collision, not invasion, but observation? What if we are already catalogued, already known, our world marked in the logbooks of an intelligence that never needed to say a word? The dark forest does not promise answers. It promises tension, the kind that grows when silence itself becomes suspicious. As Atlas rounds the sun and prepares to leave, it may carry nothing but carbon dioxide and ancient memories of its birth. Yet for those who take the whisper seriously, its silence is not comforting, it is haunting. Because in the forest of stars, quiet is not peace. Quiet is the sound of someone watching. From the very beginning, astronomers were clear. Atlas poses no danger to Earth. Its hyperbolic trajectory is precise, its closest approach distant by hundreds of millions of kilometers. It will never touch us. The mathematics are absolute, comforting in their certainty. Celestial mechanics does not lie, and yet, despite this reassurance, a different kind of unease has taken hold. An unease not born of physics, but of imagination. We are conditioned to fear impact. The scars of past collisions are written across our planet's surface, from the Yucatan crater that ended the age of dinosaurs to the Siberian blast of Tunguska. Hollywood has trained us further, filling screens with fiery impacts and desperate last-minute rescues. When the word comet enters headlines, the mind jumps to catastrophe. The discovery of Atlas was no exception. Before orbital models were even finalized, some asked the primal question, is it coming for us? The answer, firmly, is no. The numbers tell a story of safety, of a visitor that will pass by and disappear back into interstellar night. And yet, the absence of physical threat has not dispelled the psychological one. Because while the equations close the door on impact, they open another on possibility. If not collision, then what? If not destruction, then meaning? This is where the imagination stirs more deeply than gravity ever could. A rock and ice body that comes too close is terrifying in an obvious, visceral way. But a rock and ice body that does not collide, that merely passes through, unusual, alien, inexplicable invites speculation that feels subtler, stranger, and harder to shake. We are safe, yes, but perhaps safety is not the same as comfort. The psychological weight of Atlas lies not in the threat of extinction, but in the confrontation with the unknown. It is the third confirmed interstellar visitor, a category of objects so rare that each arrival reshapes our understanding of the galaxy. It travels faster than its predecessors, carries chemistry stranger than anything we've catalogued before, and approaches from angles that speak of origins in ancient stellar populations. These facts are not dangerous in the physical sense, but they tug at something older in the human mind, the unease that comes when we realize how little we understand, how much may remain hidden in the dark. So the collision never comes. Earth spins on, untouched. Life continues beneath skies that will never flare with the fire of an incoming impact. But in that very safety emerges a subtler disturbance. If Atlas is not here to kill us, then why is it here at all? The psychological threat is not the fear of dying, but the fear of being observed, of being studied, of being confronted by a reality stranger than anything we imagined. We are safe but uneasy, protected but not reassured. The danger is not in the math, but in the silence. If the models are right, Atlas may have been wandering longer than our solar system has existed. Its speed, its angle, its chemistry. They all hint at origins in the thick disk of the Milky Way, a population of stars formed when the galaxy itself was young and violent. That would make this visitor not just ancient, but primordial. A relic carrying the memory of an age when the cosmos was still assembling itself. The thought alone is staggering. To call it old is an understatement. If it truly hails from 10 or 12 billion years ago, then this object predates Earth, predates the Sun, predates every tree and ocean and living thing that has ever been part of our world. While our planet was still a cloud of dust and gas, Atlas was already moving, already exiled from its home star, already on a trajectory that would eventually inevitably bring it here. We look up and see it as new, as sudden, as urgent. But for the comet, nothing has been sudden. Its journey has stretched across geological ages, unbroken and unstoppable. This raises the question that lingers in the minds of astronomers and dreamers alike. What launched it? Natural explanations abound. A giant planet in some long-dead system might have given it the necessary kick. A near miss with a passing star could have cast it loose into the interstellar dark. Over billions of years, gravity does not need to hurry. One close encounter is enough to unbind an object forever. And yet, when we layer this natural picture with the speculative shadows, the mystery deepens. If Atlas is an ancient relic, then who or what else existed when it began its journey? Entire civilizations could have risen and fallen in the time it has travelled, leaving only silence behind. What if it was not just ejected by chance, but launched with purpose? A probe, a vessel, a seed cast across the stars by minds so old that their worlds have long since burned out. In this view, Atlas would not merely be a relic of galactic history, it would be a message in a bottle, drifting through time rather than space, carrying intentions that may no longer be decipherable. Even if it is only ice and dust, its age alone makes it extraordinary. We are staring at matter forged around a star that may no longer exist. Chemistry shaped in conditions our models barely begin to describe. Every spectrum we capture, every image we process, is more than data. It is a conversation across billions of years. We ask questions into the dark, and though the answers come only as faint chemical signatures, they still speak of places and times we will never touch. An ancient relic has arrived on our doorstep. Whether chance flung it here, or something more deliberate once aimed it our way, it carries with it the weight of deep time. To watch it glide past is to remember how brief our own story has been, and how many more stories the universe may still be hiding. Imagine technology so advanced, so enduring, that it outlives the very civilization that built it. Machines that continue their missions long after their creators are dust. Wandering across a galaxy where the voices that gave them purpose have gone silent. This is the unsettling possibility some whisper about when they look at Atlas. What if it is not just ancient rock and ice, but ghost technology still moving, still functioning, still obeying instructions left billions of years ago by hands that will never touch it again? The thought is almost too large to hold. Our own machines, even the most sophisticated spacecraft we have launched, are fragile things. Decades of exposure to radiation and dust reduce them to silence. Their circuits fail, their power fades, their trajectories eventually betray them. Yet what if somewhere out there, another intelligence solved the problem of time itself? What if they built machines designed to last not centuries but eons, durable enough to endure interstellar flight, patient enough to keep going when no one remains to listen? In this framing, Atlas becomes something more than a comet. It becomes an emissary of ghosts. If it were engineered, its disguise is flawless. It sublimates like a comet, shines like a comet, follows orbital mechanics like a comet. But beneath the surface, perhaps something more resides, a system so advanced that it can perfectly mimic nature. Its silence would then not be absence, but strategy. The ideal probe is the one that goes unnoticed, blending seamlessly with the debris of the cosmos while quietly recording, quietly transmitting, quietly persisting. And then comes the more haunting thought. What if its makers are no longer here? What if the civilization that launched it fell long ago to the same cosmic hazards that threaten all intelligence: war, scarcity, collapse? or simply the unforgiving mathematics of time. In that case, Atlas is not a messenger, not a spy, not even a probe awaiting orders. It is an orphan, a machine stripped of context, executing programs for an audience that no longer exists. This scenario changes the tone of our speculation. It is no longer about threat, but about legacy. Ghost technology would tell us that civilizations can reach extraordinary heights, solve engineering challenges we barely comprehend, and still vanish without a trace. It would tell us that the galaxy might already be littered with the ruins of intelligence, scattered among the stars as silent machines performing missions whose purposes have long been forgotten. And yet, even stripped of its creators, such a machine would still speak. Its persistence across billions of years would testify to the reality of intelligence elsewhere. Proof carved not in words or signals, but in endurance itself. If Atlas is nothing but natural rock and ice, then it is extraordinary for what it reveals about galactic chemistry. But if it is ghost technology, then it is extraordinary for what it reveals about us, our future, our fragility, and the possibility that one day, long after we are gone, our machines too will wander alone through the dark. The most unsettling visions of Atlas don't involve fiery impacts or cosmic collisions. They involve silence, patience, and strategies that unfold on timescales far beyond human imagination. Picture this: an object that looks like a comet, behaves like a comet, and passes through a solar system exactly as a comet should, but within its icy body hides something else. Microscopic devices, dormant biological seeds, or self-assembling systems designed to wait. Waiting is the key. Not minutes or years, but centuries, even millennia. This is the silent invasion scenario. No ships blotting out the sky, no lasers, no alarms, just dust and gas shedding into the void, indistinguishable from natural cometary outgassing. Inside that dust, perhaps, are microseeds, tiny machines or engineered organisms, so small they evade detection, so tough they endure cosmic radiation, so clever they know when to wake. What they wait for could be the true measure of their intent. Perhaps they are triggered by the electromagnetic chatter of a technological civilization. Perhaps they respond to atmospheric chemistry, switching on only when they sense carbon dioxide levels rising or radio transmissions flickering through the sky. Or perhaps they are far more patient, designed to remain dormant until their host world achieves a threshold of development that makes it worth their attention. The advantage of such a strategy is clear. No dramatic entrance, no alerting the inhabitants. Instead, the seeds simply ride comets and asteroids, spreading across star systems like spores. Most never land anywhere significant, and most worlds remain untouched. But all it would take is one success, one fertile planet at the right stage, and the waiting ends. Skeptics point out the near impossibility of such a system. The radiation of deep space would shred complex molecules over billion-year timescales. The violence of outgassing would scatter and destroy fragile structures. And even if some survived, the dilution factor alone would be staggering billions of seeds dispersed into an ocean of emptiness, with only the tiniest fraction ever encountering a world, let alone thriving on it. Yet, in the realm of speculation, impossibility is not the point. The point is to imagine what patience combined with technology might look like. The chilling beauty of the silent invasion idea lies in its subtlety. It reframes threat as something that doesn't need to rush, doesn't need to announce itself, doesn't even need to act in our lifetimes. If Atlas carried such a system, it could pass through, deposit nothing detectable, and continue on its journey. Decades later, or centuries, the seeds could stir. By then, the memory of this interstellar visitor would be long faded, its trail cold, its passage archived in textbooks rather than active watch lists. And yet, its legacy would remain, hidden in soil, in air, in oceans. It is speculation layered upon speculation, yes, but it captures something essential about our fears. The idea that the most dangerous invasions aren't the loud ones, they are the ones we don't see coming. The ones that already happened, unnoticed, while we were still staring at the sky in wonder. Every calculation says that small bodies shouldn't last this long. Comets, Fragile things of ice and dust are the opposite of durable. They break apart under tidal stresses, they erode under solar heating, they fracture in collisions with cosmic debris. Over millions of years, let alone billions, they should be reduced to nothing but scattered particles fading into the background of interstellar space. And yet, Atlas endures. A body that may measure only a few hundred meters across, perhaps no larger than a mountain, has somehow survived an odyssey that could stretch back to the galaxy's earliest epochs. The question presses against the boundaries of what feels possible. How? If its origins in the galactic thick disk are correct, this object has been traveling since long before Earth existed. During that time, it would have crossed regions dense with dust, endured the radiation storms of supernovae, and brushed against the gravitational fields of passing stars. Each encounter should have been a threat. Each era of cosmic violence, another chance for annihilation. Yet here it is, glowing in the telescopes of 21st century astronomers, as though the universe had granted it immunity. The natural explanations are compelling, but incomplete. Perhaps Atlas is simply tougher than most, its structure unusually compact, its volatile layers sealed beneath insulating crusts hardened by radiation over eons. Maybe its density and composition place it in the rare category of comets, capable of withstanding billions of years of punishment. Or maybe we are underestimating just how many such bodies exist, filling interstellar space with ancient wanderers, most too faint for us to ever see. That would make Atlas not a miracle, but a sample from a vast unseen population. But another thought lingers in the shadows. What if its survival is not natural at all? What if the very fact of its endurance is a signature? To persist across galactic timescales requires design materials engineered to resist decay. If so, then Atlas could be less a comet than a vessel disguised as one. Its battered shell concealing architecture beyond our imagination. A body designed to last until it found something worth observing. Or perhaps a probe designed to outlive the civilization that sent it, wandering on automatic, indifferent to whether anyone remains to receive its data. This line of speculation draws us back to the uncomfortable divide between what we know and what we fear. Natural survival is possible, yes, but design offers a cleaner explanation. To endure this long, this far, with this much intact, suggests not accident, but intention. And if intention lurks behind Atlas's improbable endurance, then its survival may not just be a story of cosmic luck. A quiet signal written not in light or radio waves, but in the very fact that it is still here at all. Before Atlas streaked into our awareness, there was another visitor that set the stage for all our present unease. In October of 2017, Pan-STARRS in Hawaii detected a faint, elongated object on a hyperbolic path. It was named Oumuamua Hawaiian for a messenger from afar, arriving first. Unlike any comet or asteroid seen before, it carried with it not just scientific puzzles but the weight of mystery, the sense that we had glimpsed something beyond our comprehension and then lost it again too quickly to ever be sure. At first, astronomers tried to place it into familiar categories. Was it a comet? It displayed no visible coma, no tail of dust or gas. Was it an asteroid? Its brightness varied in ways that suggested an extreme shape, perhaps 10 times longer than it was wide, like a cosmic shard. Then came the acceleration, subtle but undeniable. Oumuamua's trajectory shifted in a way that gravity alone could not explain. Normally such accelerations arise from outgassing, but without a coma or detectable emissions, the explanation felt incomplete. The mystery deepened when calculations showed how fast it had been moving before even entering the solar system. Like Atlas, Oumuamua was unbound, its orbit eccentricity greater than 1, its future trajectory carrying it out toward the stars forever. We had only weeks to study it before it slipped beyond the reach of our telescopes. Those brief observations became the foundation of years of speculation, arguments, and unanswered questions. For some, Oumuamua's strangeness was simply a matter of perspective, a fragment of a shattered planet perhaps, or an icy body whose volatiles had been baked off long before its arrival. The acceleration could be explained, they argued, by hidden ices releasing gas too faint to detect. Avi Loeb of Harvard gave voice to the suspicion that lingered in the public imagination. Maybe Oumuamua was not natural at all. Maybe it was a relic of alien technology, a solar sail, or a probe deliberately disguised as debris. In the years since, the debate has never fully settled. Oumuamua remains a ghost, its data incomplete, its mysteries unresolvable. We will never know with certainty, but what it left behind was not just scientific puzzles, it left behind an atmosphere of possibility. The unsettling thought that interstellar objects might not all be accidents of cosmic scattering, that some could carry intention. So when Atlas arrived, faster, brighter, and chemically stranger than its predecessors, Oumuamua's shadow stretched long across the conversation. Every reassurance about natural origins met with a memory. We've been here before. Every anomaly raised whispers of that first messenger, the one that came and went before we were ready. Atlas is not Oumuamua, yet in its mystery, it inherits the same haunting question. What, truly, passes through our solar system unseen, and what do we fail to recognize until it is already gone? If Oumuamua was the enigma that unsettled astronomy, 2I Borisov was the antidote. Detected in August of 2019 by amateur astronomer Gennady Borisov from a small observatory in Crimea, it arrived like a cosmic reassurance, a reminder that sometimes interstellar objects behave exactly as textbooks predict. From the moment its path was calculated, there was no doubt it too was unbound, an interstellar traveler sweeping through our solar system. But unlike Oumuamua, it carried with it no illusions, no strangeness hidden in silence. Borisov was a comet in every sense, behaving precisely the way comets should. Through the lenses of telescopes, 2I Borisov unfurled its bright coma, a hazy shroud of dust and gas blooming as it approached the sun. Its long tail streamed behind it, luminous against the black, whispering of sublimating ices and ordinary physics at work. Spectra taken by observatories around the world confirmed what the eye could see. Water, carbon monoxide, and other familiar molecules, signatures of a frozen body thawing under sunlight. Unlike Oumuamua, which forced scientists into speculative contortions, Borisov spoke in a language we already understood. There was something strangely comforting about this cosmic visitor. It confirmed the models that predicted the galaxy should be filled with such wanderers, icy remnants ejected from young planetary systems, cast into interstellar exile by the chaotic gravity of their birthplaces. If Oumuamua raised doubts, Borisov settled them. These objects exist. They pass through, and at least sometimes, they look exactly the way they should. Astronomers studied Borisov with an eagerness sharpened by the frustrations of Oumuamua. This time, they would not let the moment slip away. Hubble turned its gaze toward the interstellar comet, capturing images of a nucleus cloaked in vapor. The Atacama Large Millimeter Array in Chile measured its outgassing, revealing compositions strikingly similar to long-period comets native to our own solar system. Even the European Southern Observatory's Very Large Telescope recorded polarimetric data, showing dust grains that were as unremarkable as they were familiar. In every test, in every measurement, Borisov reassured us. It was natural. It was ordinary. It was above all, understandable. But ordinary did not mean unimportant. Borisov gave scientists something Oumuamua could not: clarity. It provided a control case, a baseline against which all other interstellar objects could be compared. Its behavior suggested that our solar system is not unique in producing icy wanderers, that the processes shaping our comets operate across the galaxy. Borisov's chemistry hinted at diversity, but not at alienness. It was the product of another star's nursery, but still kin to the comets that circle our own sun. In a way, Borisov was the calm between storms. It arrived after Oumuamua's haunting departure and before Atlas's unsettling arrival. Where one left us with mystery and the other with unease, Borisov offered a moment of reassurance. For a time, it allowed humanity to believe that the galaxy's wanderers were simply natural debris, not emissaries or enigmas. Yet perhaps that clarity was deceptive, a lull that made the shock of Atlas's impossible chemistry and unrelenting speed feel all the sharper when it finally appeared. The story of interstellar visitors was already strange enough. With Oumuamua's silent ambiguity, and Borisov's reassuring clarity. But then came Atlas, and suddenly the scale shifted again, faster than either of its predecessors, chemically stranger, and possibly older than our solar system itself. It demanded not just observation but interpretation. Was it an outlier, the rare product of extreme cosmic conditions, or was it something more, an intentional messenger disguised as chance? The numbers alone set it apart. Oumuamua's speed impressed, Borisov's was familiar, but Atlas raced inward with a hyperbolic excess velocity of 61 kilometers per second, nearly twice that of its interstellar kin. That speed meant energy, and energy meant history. To reach such velocities required either violent ejection from its natal system or the accumulation of gravitational slingshots across galactic time. Each possibility carried implications. Violence suggested a chaotic origin, a world torn apart and scattered. Accumulation suggested endurance, an object that had been wandering long enough to gather the push of countless stellar encounters. Either way, its velocity alone hinted at something extraordinary. Then came the chemistry. Where Borisov had offered comfort with its familiar blend of water and carbon compounds, Atlas defied expectation. Webb's infrared spectrograph revealed a coma dominated by carbon dioxide, with ratios no comet in our system had ever displayed. It was as if its molecular fingerprint had been written in a dialect we could barely decipher. Natural explanations existed: formation near a CO2 snowline, radiation-hardened crusts, insulating mantles, but none erased the strangeness. This was not the chemistry of the neighborhood we knew. It was alien in the truest sense, a sample of conditions from a stellar nursery, utterly unlike our own. Age deepened the mystery. Its trajectory and galactic approach suggested thick disk origins, meaning it could have been traveling for billions of years, launched long before Earth formed its oceans. If true, Atlas carried within it the memory of a galaxy that no longer exists, the Milky Way of its youth, when stars were born in violent bursts and chaos reigned where order now holds sway. It was less a comet than a time capsule, drifting through epochs we can only model in equations and imagine in simulations. When placed side by side, the three interstellar visitors form a progression that resists easy interpretation. Oumuamua whispered mystery, Borisov spoke clarity, and now Atlas shouts strangeness. It is faster, it is chemically alien, it is older by far. Outlier, messenger, the choice of interpretation may reveal more about us than about it. We search for patterns, we fear the silence, we wonder whether chance alone can account for so much improbability. Perhaps Atlas is nothing more than cosmic debris, remarkable only because we happen to notice it. Or perhaps it is what every outlier is, a messenger, not in the literal sense of alien design, but as a reminder that the universe is not obligated to conform to our expectations. Sometimes, the message is simply that we still know very little about the world beyond our star. At first, Oumuamua seemed like a once-in-a-lifetime discovery. A single sliver from another star system, tumbling past us before we even had the chance to study it properly. Then came Borisov, so soon afterward that astronomers began to wonder whether interstellar objects were far more common than we ever realized. And now Atlas, discovered not by chance but by expectation. The question is unavoidable. Why are we seeing more of them now? Has the galaxy suddenly decided to send its wanderers our way, or has something changed in us? The truth may lie in our eyes, not in the sky. Our telescopes have grown sharper, our surveys wider, our computers faster at sifting through the endless drift of starlight. The Vera Rubin Observatory, still preparing for full operations, promises to expand this revolution even further. Each generation of instruments has peeled back another layer of invisibility, revealing that what we once thought rare may only have been hidden. Interstellar objects have likely always been here, cutting through our solar system unnoticed, their fleeting passages lost in the noise of stars. The cosmos has not changed our ability to perceive, it has. But the frequency of discovery carries psychological weight beyond statistics. Once can be dismissed as chance. Twice feels like a pattern. By the third, our instincts lean toward meaning. We imagine narratives, sequences, escalating encounters. The ambiguous first, the clear second, the strange third. The story writes itself whether or not the universe intended one. Each detection stirs the sense that we are participants in something larger, that these wanderers are not random debris but chapters in a conversation we do not yet understand. There is also the question of timing. Why do these discoveries cluster in our era rather than in the centuries when comets terrified kings and guided myths? The answer again points to technology, but it also touches something deeper. We are a young species, still learning to look beyond our own horizons, and the interstellar arrivals remind us that we are latecomers to an ancient game. The galaxy has been seeding space with wanderers for billions of years, long before our telescopes, long before our cities, long before our oceans teemed with life. That we are only now beginning to notice them does not make them new. It makes us newborns opening our eyes for the first time. Yet the frequency question lingers, because patterns can be real as well as imagined. If surveys continue and the sky reveals dozens, then hundreds of interstellar visitors, we may find that our solar system is not merely a quiet backwater, but a crossroads of galactic traffic. Some will be ordinary, some strange, and perhaps one day, one may not be natural at all. The more we look, the more the silence of the cosmos will either deepen or fracture. The frequency of discovery does not simply measure how many objects pass us. The galaxy is not empty. Every model of planetary formation insists that trillions of icy shards and rocky fragments must have been cast adrift during the violent births of countless solar systems. They wander now, nameless and invisible, ghost traffic in the interstellar dark. Most will never pass near another star. A few will, slipping like thieves into alien neighborhoods before vanishing again. Our telescopes, sharpened only in recent decades, have caught 3 of them in as many lifetimes. Statistically, there should be millions more. That abundance forces a haunting calculation. If even 1 in a million is not natural, then the sky hides needles of staggering significance. This is where imagination collides with probability. If civilizations have ever risen elsewhere, even once in the deep time of the galaxy, they might have left relics behind. Probes, seeds, machines designed to last longer than stars. A perfect disguise, because it is not a disguise at all. The camouflage is statistical. Flood the galaxy with trillions of wandering stones, and a handful of engineered objects disappear into the noise. We would need to sift with impossible patience to notice the anomaly. The challenge is not just technical, it is philosophical. What does artificial even mean when filtered through billions of years? A probe from an extinct intelligence would no longer look like technology in any familiar sense. It might be eroded, dormant, its architecture reduced to patterns in chemistry or resilience against time. To us, it might resemble nothing more than a comet that survived too long, a rock that carries too much order in its randomness. The signal may be so faint that only the backdrop of countless others makes it stand out. 3 interstellar objects do not give us that backdrop. They give us a whisper of a population too vast to fathom. Oumuamua hinted at strangeness, Borisov at normality, Atlas at something in between. Already the temptation is to rank them, to see them as characters in a cosmic narrative. But real understanding demands numbers, not stories. We need dozens, hundreds, thousands of detections. Only then can patterns emerge, and only then might a true outlier betray itself. The needle in the haystack will not gleam. It will look like straw, until the statistics reveal otherwise. The possibility that one day we will catch such an outlier is both exhilarating and unsettling. For hidden in that single artificial among millions lies proof that the universe once held voices other than our own. Perhaps it still does. The search, then, is not only about counting wanderers, but about learning to recognize when silence breaks not with a shout, but with the quiet persistence of a pattern that nature alone cannot explain. When Hubble turned its ancient glass toward Atlas, the images that came back looked deceptively ordinary. A faint star smeared into a fuzzy glow, a coma spreading like breath on cold glass, and a thin suggestion of a tail curling away from the sun. For decades, this is what comets have looked like through Hubble's patient eye. Classic, familiar, textbook. To the casual observer, nothing here would raise alarm. But within those familiar forms, astronomers know Hide details that speak in whispers rather than shouts, details that can either reassure or unsettle, depending on how you read them. The portraits revealed a textbook comet, and yet not quite. The coma bloomed too strongly for the object's distance, hinting at a chemistry not driven by water ice but by something else, more volatile, more alien. Each pixel of light in Hubble's detectors carried information about size and brightness, about dust scattering and gas escape. Together, they formed the most public face Atlas would ever present to Earth, a face both familiar and strange. For those who wanted to see nothing more than another comet, the portraits offered comfort. For those who suspected something deeper, the same portraits became masks. Because this is what makes Hubble's images so haunting. They are not high-resolution blueprints that lay a nucleus bare. At best, Hubble resolves a blur where the solid core hides inside a cloud of its own escaping atmosphere. The true shape, the true structure, remains concealed within its luminous veil. An object designed to masquerade as natural could hardly choose a better disguise. To look at a comet is to see nothing but what it chooses to shed. The nucleus keeps its secrets. Even as Hubble's portraits circled the globe, released to the public with careful captions and technical footnotes, the deeper question simmered. The perfect camouflage is not invisibility, but conformity. Hubble's classic comet photographs may be the very reason we stop asking dangerous questions. The irony is that the most advanced telescope of its generation gave us images that feel comfortingly antique. A ball of dust, a halo of gas, a tail in sunlight. Children's drawings of comets match Hubble's output, and in that familiarity lies both reassurance and danger. We trust what looks normal, but what if the extraordinary hides best behind the ordinary? The portraits of Atlas, then, are not just astronomical records, they are psychological tests. They ask whether we are satisfied with the mask, or whether we dare to imagine what might be hiding behind it. The comet's face, captured in Hubble's careful eye, smiles back at us from the void, daring us to wonder whether the light we see is a natural glow or a carefully chosen illusion. The James Webb Space Telescope did what it was built to do: strip away the blur of distance and reveal the fingerprints of chemistry with surgical precision. When its instruments locked onto Atlas, astronomers expected confirmation of the usual suspects: water vapor, carbon monoxide, dust laced with familiar minerals. Instead, Webb delivered a spectrum that unsettled more than it clarified. Line after line, the molecular signatures trace not the expected balance of ices, but a dominance of carbon dioxide so overwhelming that it eclipsed every model of cometary chemistry. 80 parts CO2 for every 1 part water. Ratios so skewed they looked less like a frozen relic of some ancient star system, and more like the controlled output of a process we do not yet understand. At first, there was excitement. Anomalies drive discovery, and astronomers crave the unexpected. Perhaps the comet had formed near the carbon dioxide snowline of its parent star's protoplanetary disk. Maybe cosmic rays had processed its surface for eons, sealing water beneath and leaving CO2 to dominate. Or dust mantles had locked away other volatiles, creating an artificial seeming imbalance. Yet none of these scenarios sat comfortably with the scale of the numbers. They were theories patching holes in a dam that refused to break. Webb's spectra did not merely show chemistry, they suggested behavior. Even at distances where most comets slumber, Atlas was active, exhaling a coma of carbon dioxide visible across hundreds of thousands of kilometers. A whisper that the object was awake before it was supposed to be. For those willing to speculate, the question came naturally. Was this activity a natural quirk, or the first sign of systems responding to solar light in ways more deliberate than random heating? The data unsettled because it resisted translation into familiar categories. If it were merely natural, it was stranger than any comet we had catalogued. If it were not, then the implications opened doors we are not ready to walk through. Webb, in its perfection, gave no comfort, no ambiguity to hide behind. Just clean, sharp lines where carbon dioxide shouted louder than anything else. The spectra became Rorschach tests. To some, they revealed alien formation conditions, exotic but natural, proof that our galaxy is more chemically diverse than we imagined. To others, they looked like signatures, ratios so stark they resembled codes, as if chemistry itself might be a carrier of information. The truth remained stubbornly out of reach. In the end, Webb showed us exactly what was there, and in doing so, deepened the mystery. The telescope's precision cut through noise, but clarity is not the same as understanding. Sometimes the sharpest image leaves us with the most blurred conclusions. And so Atlas remains an object, defined as much by the questions it provokes as by the answers it withholds. Silence has a weight in astronomy, heavier than any data point. When radio telescopes swung toward Atlas, the hope, however faint, was that something structured might emerge from the static. A narrowband whisper, a repeating pulse, a sign that nature was not the only author of this visitor's story. Instead, what came back was the familiar hush of space. Broad, chaotic noise generated by natural processes, the hiss of charged particles meeting solar wind, the faint electromagnetic echoes expected from dust and ice. Nothing more, and yet nothing less. For decades, SETI researchers have wrestled with the paradox of silence. In a galaxy teeming with stars, with planets in abundance, with chemistry that seems to invite life, the absence of any artificial signal feels less like absence and more like strategy. Silence can be accidental, born of distance, technology mismatches, or the sheer weakness of signals smeared thin across light years. But it can also be deliberate, a choice by civilizations wise enough to know that broadcasting is a declaration. And in a dark forest, declarations are dangerous. When Atlas passed under the collective gaze of our listening instruments, the silence it carried became another chapter in this ongoing puzzle. If it were truly a disguised probe, designed to watch but not be seen, then silence would not just be expected, it would be the very point. A perfect camouflage is not the object that blends into the background, but the one that emits nothing that could betray intent. To our ears, tuned to catch signals that look like ours, the quiet could be the loudest confirmation that something is listening back, choosing not to speak. For the cautious, this silence was reassurance. No signal means no threat. No machinery hiding inside a comet's body. No alien intelligence waiting for our reply. The universe remains natural, vast, and indifferent. But for others, the reassurance rang hollow. Because silence does not close possibilities, it multiplies them. Is it that we are truly alone, or that we are so far behind on the ladder of detection that what's obvious to them is invisible to us? The SETI silence around Atlas is not unique. Every object, every sweep of the sky, every careful survey has returned the same empty canvas. It is a pattern, and patterns matter. The absence of noise becomes its own data set, whispering that either civilizations are rarer than we hope, quieter than we expect, or far more cautious than we dare to be. So the silence persists, and with it, unease. A comet that might be nothing more than frozen gas and dust has reminded us of the larger truth. Sometimes the universe answers not with a shout, but with a refusal to speak. And in that refusal lies the most haunting possibility of all, that the quiet is intentional. When the story of Atlas broke into headlines, it didn't arrive as raw data or orbital plots. It arrived as words and images, sculpted by choices about what to emphasize, what to soften, and what to leave unsaid. The media dilemma emerged instantly. How do you tell the public that an object from another star system is racing toward the sun without turning science into spectacle, or reassurance into boredom? Too much emphasis on danger, and panic takes root. Too much emphasis on safety, and the wonder evaporates. Between those poles, the truth struggles to breathe. NASA's statement set the tone early. Calm, measured, unequivocal. No threat, no collision, nothing to fear. The press releases spoke the language of orbital mechanics, precision trajectories, and safe distances. The words were chosen carefully, designed to inoculate against the fever of speculation. Yet in the space between those reassurances, imaginations rushed to fill the void. Journalists knew that Comet behaves exactly as predicted would not hold public attention for long. So headlines bent toward mystery. Fastest ever, strangest chemistry, third of its kind. The balance tipped between sober fact and the irresistible pull of narrative. Social media magnified the dilemma. Threads, posts, and videos spun fragments of real science into webs of speculation, some thoughtful, others designed only to provoke fear or clicks. In this echo chamber, Atlas became whatever the audience wanted it to be: an omen, a weapon, a messenger, a myth. Each retelling distorted the proportions between evidence and possibility, feeding both awe and anxiety. The algorithms rewarded the extremes, while the careful middle patient explanations, nuanced uncertainty struggled for visibility. For scientists, the tension was sharper still. Their duty was to the data, to present what was known and nothing more. But they also understood the power of framing, describe the comet as ordinary, and the funding for telescopes dries up. Describe it as extraordinary, and suddenly the public fears what lies behind the word. The tightrope between inspiration and alarm is thin, and each misstep has consequences. History shows how fragile this balance can be. The wow signal in 1977, the fleeting mystery of Oumuamua in 2017, the endless debates about UFOs, each was shaped not just by what was discovered, but by how it was told. In every case, the narrative that captured the imagination was the one least tethered to certainty. The lesson is clear. When the universe offers mysteries, humanity will always choose the story that feels larger than life. The media dilemma of Atlas is not about lies or truths, but about scale. How do you compress a billion-year journey into a headline without distorting it? How do you show the wonder of ancient chemistry without hinting at danger? How do you honor the science while acknowledging the shadows that speculation inevitably casts? Perhaps the real answer is that you can't. You can only hold the tension, letting fear, wonder, and truth coexist, each whispering to the audience in turn. Science advances not only through discovery but through restraint. Every new observation arrives tangled in uncertainty, and the role of the scientist is not merely to collect data but to weigh it against imagination. With Atlas, this balance has never been more visible. From the moment calculations confirmed its interstellar trajectory, astronomers faced a dilemma as old as inquiry itself. How do you remain open to the extraordinary without succumbing to it? Skepticism forms the bedrock. Extraordinary claims demand extraordinary evidence, and nothing about Atlas has yet broken free of natural explanation. Its speed, though unusual, fits within the wild variance of ejection physics. Its chemistry, while unprecedented, can be modeled by exotic but plausible formation conditions. Its silence on the radio spectrum mirrors countless other comets. The skeptics remind us that nature has always proven stranger than our expectations, and that labeling anomalies as artificial is a failure of imagination, not an expansion of it. And yet, openness tugs at the edges. This is the third interstellar visitor ever detected. It is faster, stranger, older than its predecessors. The unusual carbon dioxide dominance resists easy explanation. The angle of its arrival hints at origins deep in the galaxy's thick disk, in stellar nurseries that predate our Sun by billions of years. Each fact alone is unremarkable, but together they form a mosaic that whispers possibility. Could this be more than a comet? Could the very precision with which it mimics natural behavior be part of its disguise? To deny the question outright would be as unscientific as embracing it without proof. This is the delicate balance. Too much skepticism, and the field risks closing itself off from transformative discoveries, dismissing anomalies before they can rewrite theory. Too much openness, and science dissolves into speculation, indistinguishable from myth. The astronomer's task is not to silence either voice, but to let them argue within the bounds of evidence, to cultivate a discipline where imagination and restraint sharpen each other like blades. History is littered with cautionary tales on both sides. Pulsars were first thought to be little green men, before their true nature as neutron stars was revealed. Quasars baffled astronomers with their brightness until models of supermassive black holes emerged. The cosmos routinely presents phenomena that masquerade as impossible until they become obvious. To dismiss Atlas's oddities too quickly risks repeating that mistake. But to leap toward alien intention without proof would collapse the credibility of the very institutions tasked with finding truth. In the end, skepticism and openness are not opposites but partners. Together, they allow humanity to approach the unknown without surrendering to fear or fantasy. With Atlas, that partnership is on full display. The comet may be natural, and it may not. What matters more than the answer is the process, the disciplined curiosity that holds both possibilities in mind until the universe itself tips the scales. The idea lurks in the background of every conversation about alien life. If the universe should be teeming with civilizations, then why does it seem so silent? This riddle, known as the Great Filter, suggests that somewhere along the path from chemistry to intelligence to interstellar expansion lies a barrier so formidable that almost no one passes through it. For humanity, the question is not only where that barrier sits, but whether we have already crossed it, or whether it still lies ahead. Against this sobering backdrop, Atlas becomes more than a comet. It becomes an echo, a messenger not of presence but of absence. Imagine for a moment that Atlas is not simply debris flung from a planetary nursery billions of years ago. Imagine instead that it is a relic, a wandering artifact of a civilization that never survived long enough to greet us. Its carbon dioxide dominance, its extreme velocity, its very antiquity could be the chemical handwriting of a people who engineered marvels across the stars only to fall silent before they could leave a legacy. In this vision, Atlas carries not surveillance equipment or hidden seeds, but testimony. Testimony that even civilizations capable of shaping matter at the scale of worlds can collapse into the quiet of history. The chilling possibility is not that we are being watched, but that we are reading the ruins of the unwatchable. Cosmic debris, yes, but debris that whispers of ambition cut short, of intelligence extinguished by forces too great to overcome. The silence of SETI, the emptiness of the skies, the absence of unambiguous alien signals, these may all be symptoms of the Great Filter at work. Perhaps we are latecomers wandering a graveyard galaxy where comets like Atlas are the only epitaphs left behind. What makes this speculation sting is how ordinary the object appears. No blinking lights, no impossible maneuvers, no transmissions humming through the void. Just ice, dust, and gas behaving as physics dictates. And yet, that very ordinariness might be the most haunting detail. If Atlas is indeed the byproduct of a dead civilization, then time has stripped it of all but its most elemental nature. Whatever it once was, whatever it once carried, is gone, leaving only silence and the memory locked in orbital eccentricities and chemical fingerprints. For us, the echo functions less as warning than as mirror. If the Great Filter awaits in our future, then the fate of Atlas's hypothetical makers could one day be ours. Our machines, our cities, our signals might vanish, leaving behind only fragments of chemistry to drift among the stars. And if we have already passed the filter, if our survival is the exception, then every interstellar object we study becomes a reminder of how rare and precarious our position may be. So when astronomers chart Atlas's course, when they measure its spectra and announce its harmless passage, they may also be recording something deeper. Not just the trajectory of a comet, but the faint echo of civilizations erased by time. It is one thing for an object to wander into our solar system. It is another for it to do so now, when humanity is uniquely prepared to notice. For billions of years, Atlas may have been coursing through the dark between stars, unseen, anonymous, indistinguishable from the trillions of other wanderers adrift in the galaxy. Yet, its arrival coincides precisely with an age in which our telescopes never sleep, our sensors sweep the heavens with tireless precision, and our species has both the curiosity and the technology to capture its brief passage. The timing is almost too perfect, almost theatrical. Skeptics insist this is nothing more than probability playing out on a grand scale. Interstellar objects should number in the countless billions, their random trajectories ensuring that some will pass through our solar system. Given enough time and the growing sophistication of our instruments, discovery was inevitable. And yet, inevitability does not erase the uncanny resonance of the moment. Out of the infinite expanse of cosmic possibility, Atlas arrives at the precise juncture when human eyes are open wide enough to see it. The coincidence tempts darker thoughts. What if the timing isn't coincidence at all? What if Atlas, whether natural or not, represents something more deliberate. A test, perhaps, delivered only once our species had reached the technological adolescence necessary to notice. After all, what better way to be recognized by a civilization just stepping into its astronomical awareness than to arrive in its line of sight, precisely when it has the tools to detect you? Some scientists recoil from such speculation, preferring the safety of chance and statistics. But history reminds us that humans rarely encounter the unexpected without attaching meaning. When Halley's comet returned in 1910, panic gripped parts of the world, driven by superstition rather than science. Now, in 2025, we are wiser, yet still haunted by suspicion. If the cosmos wanted to whisper, would it not choose this exact moment? An era where we can see but not yet touch, where we can analyze but not control? The darker side of timing is that it plays directly into our deepest fears of significance. If Atlas arrived a century earlier, it would have slipped by unnoticed. A century later, perhaps it would be catalogued with calm efficiency, one among many such wanderers. But arriving now, as one of the first interstellar visitors we have ever confirmed, it takes on disproportionate weight. We cannot help but ask why it appears at this fragile intersection of human history, when our species teeters between mastery of space and the risk of collapse. The truth may be simple randomness, yet the effect is indistinguishable from design. A cosmic messenger materializing exactly when we are watching, exactly when we are ready to wonder whether its timing is an accident or an answer. Fear is a measurement, as real as the light curves plotted by astronomers or the spectral lines etched across Webb's instruments. When Atlas streaked into awareness, it did more than challenge models of chemistry or orbital mechanics. It probed us. The object became a mirror, and in its reflection we saw not an alien messenger or cosmic threat, but ourselves, revealed in how we respond to the unknown. From the first announcement, fear ran parallel to curiosity. NASA's calm assurances, no danger, no threat, were repeated in headlines across the world, but beneath the words lay an undercurrent of unease. Why, people asked, must the experts emphasize safety so strongly if there were truly nothing to fear? Anxiety, it seems, is written into our wiring. The primitive brain still flinches at what approaches from the dark, even when told it will pass at safe distances. In online forums, speculation blossomed like spores in damp earth. Was Atlas a probe, a weapon, a disguised arc drifting between the stars? The comet's silence did not quiet these questions, it amplified them. And in every rumor, every fearful projection, we find data points not about Atlas, but about humanity itself. Our stories of invasion, hidden watchers, or silent judgment reveal less about what the object is, and more about what we dread becoming, or what we secretly hope to find. Fear, after all, is a form of anticipation. It tells us what futures we imagine most vividly. The notion of a decelerating probe disguised as ice and dust speaks to our suspicion that intelligence must be watching us, even if we cannot see it. The idea of microseeds hidden in the nucleus reveals our unease with biology, contagion, and the loss of control. The dark forest hypothesis, whispered in speculative corners, reflects our awareness of our own predatory instincts projected outward onto the galaxy. Each fear is a confession, data about our psychological landscape, encoded in the stories we invent when the cosmos delivers something strange. Scientists track the trajectory of Atlas with exquisite precision, but culture tracks it with metaphors. Every headline, every viral post, every hushed conversation over dinner tables becomes part of the data set. We learn, by watching ourselves, how deeply we yearn for connection and how profoundly we mistrust it. Fear reveals our paradox. We want the universe to notice us, and we desperately want it not to. In this sense, the worst-case scenario may already be happening not in the comet itself, but in us. Not because Atlas is a probe or a threat, but because its arrival exposes just how fragile our balance is between wonder and dread. If we fear too much, we close the door to discovery. If we fear too little, we may stumble unprepared into whatever truths the universe eventually reveals. Atlas may be nothing more than ice, rock, and carbon dioxide, But the shadow it casts is psychological, stretching across our species. In its passage, it has already delivered a kind of message. Fear itself has become the data, and we are the experiment. When the imagination runs too far ahead, when whispers of probes and invasions swirl through headlines and late-night conversations, physics offers its steady hand. Numbers, immutable and indifferent, remind us that Atlas is not chaos but calculation. Its path is written in the language of gravity, its velocity plotted on charts with margins of error measured in fractions. Against speculation, mathematics speaks with the calm authority of inevitability. This is where it came from. This is where it goes. This is how close it will pass. And this is when it will leave. Astronomers take comfort in this predictability. The Minor Planet Center's bulletins update orbital elements as though they were pulse checks, each refinement narrowing uncertainty until the trajectory becomes as solid as stone. In those numbers, there is no room for panic. Atlas will not collide with Earth. Its perihelion can be forecast to the hour. Its outbound path arcs cleanly back toward the dark, never to return. Whatever else it may be, natural or otherwise, it is still bound by the same equations that govern planets, moons, and every comet before it. The universe may be strange, but its strangeness still obeys law. This is the quiet beauty of celestial mechanics. Where imagination conjures intention, physics reveals inevitability. The smooth hyperbola traced by Atlas is not the improvisation of a visitor, but the choreography of mass and motion. Radiation pressure nudges it, outgassing adds subtle perturbations, but every force is catalogued, every influence anticipated. The apparent wildness of a comet's path reduces to equations children can learn to write. For the public, orbital diagrams offer a peculiar kind of reassurance. To see a comet's future sketched out for decades to come is to confront uncertainty with certainty. No hidden maneuvers, no sudden turns, no surprises waiting in the dark. Just the serene arc of mathematics carrying the object out beyond the reach of our telescopes and back into anonymity. Even the velocity that unsettled scientists at first faster than models predicted becomes less threatening when framed in the steady language of energy exchange, stellar ejections, and galactic pinball. Physics does not eliminate mystery, but it contains it, keeps it from spilling into panic. And yet, the comfort of physics is double-edged. The very precision that reassures also reminds us how small we are in comparison to the machinery it describes. We can plot the comet's path, but we cannot alter it. We can calculate its speed, but we cannot slow it. We can know, but we cannot act. The numbers are not negotiable. They leave us spectators, comforted but powerless, watching inevitability glide past. Perhaps that is the deepest reassurance of all that. In a universe filled with uncertainty, there remain anchors. Equations that hold true across billions of years, laws that do not change no matter how far from home we look. In their steadiness, we find calm. Amid fear and speculation, physics gives us what no story can: silence, certainty, and peace. For as long as we've tracked it, the numbers have told a reassuring story. Atlas is on a hyperbolic course. It came from beyond, it will sweep around the sun, and then it will vanish back into interstellar night. The math is solid, the trajectory clean, the predictions precise. But what if the very neatness of that story is the illusion? What if leaving is not the end of the tale, but part of the plan? We assume departure means safety, that when it slips away, glowing faintly as it fades into the black, the mystery will end and the questions will quiet. Yet departure itself might be the most convincing disguise of all. A civilization advanced enough to cloak technology in ice and dust would surely understand psychology as well as physics. They would know that nothing calms fear faster than distance. Nothing reassures more than the sight of something vanishing into the horizon. If you wanted to observe undisturbed, to watch without interference, would you not design your probe to appear to leave? The unsettling thought is not that Atlas lingers visibly among us, but that its true instruments, its hidden fragments or subsystems, are already scattered. What if the main body is nothing more than a decoy, its exit, a carefully choreographed gesture while the real presence remains. In such a scenario, the departure is not the end of contact, but the beginning. The sky clears, the calculations confirm escape, the scientists close their notebooks, and we relax. And in that moment of relief, the work of surveillance could truly begin. It is almost too paranoid to imagine, yet the pattern resonates with human history. Explorers across oceans planted flags, then appeared to leave, while their maps and messengers returned quietly. Spies in every era crafted elaborate illusions of absence while gathering information unnoticed. The cosmos may simply operate at scales and timescales too vast for us to recognize the same strategies. We mistake silence for peace, distance for safety, departure for closure. But what if those are the very misperceptions that make us easiest to study? Atlas continues to trace its perfect curve outward, the kind of graceful departure that should invite relief. And yet the thought lingers like a shadow. Perhaps leaving is exactly what we were meant to see. Silence is not absence. It is information, waiting to be read. As humanity wrestles with the enigma of Atlas, one unsettling possibility grows clearer. If this object is more than stone and ice, then perhaps its mission requires nothing more than watching. What if every question we ask, every headline we write, every signal we send into the void is part of the experiment? A civilization advanced enough to send disguised probes across interstellar distances would not need to act loudly. It could learn everything it needs from the ripples of our response. The calculations, the debates, the reassurances, the fears, they all reveal something about us. Our level of technology, our philosophical readiness, our anxieties and our strengths. If so, then the silence of Atlas is not failure to communicate, but a choice. A perfect mirror, reflecting our own reaction back at us. It does not need to reveal itself, because what matters is how we reveal ourselves. The object glows faintly in the sky, trailing its coma like countless comets before it. But the true signal may be flowing in the opposite direction, carried not in radio waves, but in human behavior. In this light, the distinction between natural and artificial almost ceases to matter. The presence of Atlas, whatever its origin, has already altered us. We measure, we speculate, we fear, and if somewhere, something is watching, then our reaction alone may be the data it seeks. Whether we greet the unknown with curiosity or paranoia, with cooperation or division, may be the only test that matters. This interpretation leaves us with a paradox more troubling than any chemical anomaly or orbital irregularity. If the watchers are silent, then our own voices fill the void. If they do not act, then our actions stand as the only record. The danger may not lie in what Atlas does, but in what it draws out of us. Perhaps that is the deepest silence of all, the realization that even if nothing stirs within the icy shell, even if no alien machine waits behind the coma, the presence of this interstellar visitor has already observed us, and in its silence, it has already learned what kind of species we are. The phrase worst-case scenario usually summons visions of fire and collision, of skies torn apart by impacts and civilizations ending in dust. With Atlas, that nightmare was dismissed almost as soon as it appeared. The orbit is clean, the distance safe, the mathematics certain. It will not strike us. But the absence of physical danger does not close the question. Instead, it sharpens it. Perhaps the worst case was never about rocks and trajectories at all. Perhaps it was about what we would have to confront in ourselves once the object appeared. Because the danger of Atlas lies in what it makes undeniable. We are no longer dealing with abstractions. For generations, the possibility of interstellar wanderers was theory, a line in computer models, a probability whispered in scientific journals. Now they are real, and they are arriving with unsettling frequency. Oumuamua first startled us, Borisov reassured us, and Atlas has unsettled us again. The pattern alone is enough to stir unease. If the galaxy is filled with such travelers, then the question of their nature can no longer be pushed aside. And that question leads directly to the two possibilities we fear most. The first is that we are not alone, that one of these wanderers, perhaps Atlas itself, may carry within it intention, not a comet but a device, not a relic, but a message. The thought thrills and terrifies in equal measure. If we are observed, then we are vulnerable. If we are contacted, we may not survive the encounter unchanged. The silence of Atlas offers no reassurance because silence can be strategy. If the object is more than dust and gas, then perhaps it already knows more about us than we know about it. The worst case here is not invasion, but exposure. The realization that we are being studied, patiently, invisibly. The second possibility is darker still. That we are alone. That Atlas is nothing but debris, as natural as any comet, and that every interstellar visitor we will ever detect will tell the same story. That the galaxy is littered with fragments, but not with voices. That civilizations either never rise or never last. In this scenario, Atlas becomes a reminder not of company but of silence, of absence. And if absence is the truth, then the filter that silenced others may yet await us. So the comet drifts past, and the sky does not fall. But in its wake, the weight of realization lingers. Maybe the danger is not an impact that never comes. Maybe the danger is knowledge itself, knowledge that we might be watched, or worse, that we are not worth watching. The worst case may already be happening, quietly, invisibly, in the space between what we observe and what we fear. In that silence, we are left with the most human of tasks: to wonder, to imagine, and to hope that when the next messenger comes, it will bring not dread but clarity.